in addition to being an Amazon Web Services Solutions Architect, I have extensive experience in cybersecurity, both in the national security space, as well as in the civilian, private sector, and corporate space. So some of that is going to translate into what we discussed today. And we do have quite a bit to discuss today, because when we're dealing with the subject matter of security in the cloud, it's really no different than talking about the entire industry of information system security, because ultimately we attempt to emulate what we do in on-prem systems within the cloud. And the difference is simply that you have to use a great deal of virtualization and remote control to do the same thing. So we don't have enough time in this introduction in this webinar to cover all aspects of security, obviously, since it's entire industry and a huge field of study. But we will hit a number of key topics. I just want to say from the outset, it has become a very significant area of focus across our industry to look at security in greater detail than we had before. In many cases, security has been an afterthought, more or less thought of as fence building, something that you do to take care of the necessary threats. But really, the focus has tended to be on the capabilities that an organization is seeking to leverage from information technology, whether it's on the web as part of some sales strategy, or purely a communications play, or whatever the role of information technology is. Generally, the capability takes front seat. Security has for many years taken back seat. But we now live in a world where people are waking up to the realities of various cyber threats. And with that has come a whole era of cybersecurity and the professionalization of the field of really developing sophisticated solutions for risk mitigation and defensive technologies and practices. I mean, just a set of threats that come to mind are listed here in the slide that you can all see, and hopefully everyone can see everything. I didn't mention this at the outset. Let me say this now. We will have a time for question and answers at the end. But for now, please just log your questions in the chat box, and we'll get to them at the end of the discussion. But whether the concern is social engineering, spoofing, session hijacking, DDoS attacks, whether the motivations is theft or some sort of industrial espionage, or even the threat of foreign nationals seeking to undermine the capabilities of a national enemy. All of these things fit together to create a challenge for organizations who utilize information technology to ensure that their systems are in fact protected. So what we're going to do is we're going to look at AWS very superficially as a whole. We'll look at some of the core principles of information system security, how the cloud environment implements what we call the shared responsibility model. We'll look at the different tiers of services, the three big ones. And of course, we recognize that there's more to cloud than infrastructure as a service, platform as a service, and software as a service. But those are the big three that allow us to kind of create a framework around our discussion. We'll look at the infrastructure. We'll look at some core mitigations like DDoS mitigation, the use of encryption, IDM, vulnerability management, and cyber hygiene, monitoring, logging, and various techniques to ensure that you have a hardened environment. And if you are an organization that needs to meet regulatory requirements, we'll talk a little about governance, risk management, and compliance management, how that works in the AWS environment. First, just want to say right from the outset, Amazon Web Services puts security as a very high priority. In fact, some would say it's the highest priority. And that makes sense, because who's going to trust an outside organization to manage your system, your critical information, your business processes, the backbone of your organization's day-to-day knowledge work, to an organization that doesn't do good security? And because of this, what you'll find is, for the most part, Amazon Web Services presents a stronger security baseline than most organizations do or even could achieve within their budgets and priorities. We'll look at data center and network architectures that are built to satisfy not just the needs of an organization that's capability-centric, but even the most security-sensitive organizations you can imagine. Among the customers are not just commercial entities, but governmental entities. The US government, even in some cases, US military utilizes AWS systems for certain applications. So these organizations are extremely sensitive to the security concerns and are high-risk targets that have many adversaries seeking to exploit any vulnerabilities if they can be found. So to satisfy those sorts of clients, AWS is, if anything, over-engineered for security. The other significant point to AWS security, just on the whole, is that it's built around the model of scalability and innovation. So that not only do you have security measures that meet state-of-the-art requirements, as you scale a system up, as you operate in what is its natural environment, a global distributed environment, the security is maintained across the various tiers of utilization of these services. In some cases, you'll find that not only do you get more security, generally, actually, I would not even say generally, pretty much without exception, the security services are available at substantially lower costs than imitating or emulating the same level of security. The objectives are for visibility, auditability, controllability, and agility. The goal is to give everything that an organization would want in terms of security at a cost-effective approach, implementing all the best practices, whether it's policies, architecture, operational processes, what have you. Delivering the highest availability, potentially the lowest latency, and the best security that's possible with 24/7 monitoring and data center physical security controls. So with all that, there's a lot to the benefits of utilizing the cloud environment, and particularly AWS as your platform or your infrastructure for hosting your organization's systems and services. And you could even say that AWS solves some of the major problems that are incumbent in implementing a system security strategy for a system or an organization or whatever the needs may be. And that's because very often the way organizations are set up, there is a definite separation. And some of that separation is a necessary evil, but there's separation between operations and security. So there can often be a lack of visibility into the systems and the usage of the systems by the information system security professionals that work for that organization. And with those separation of duties, which again, there's some benefits to, it creates a problem for ensuring the auditability and monitoring and security implementation that an organization would really need to have in place. Another issue that is obfuscated by AWS is the lack of automation. And that's because to host something on the web, you have to have visibility because everything's managed by remote control, and you have to have automation, since a user of AWS will rarely, if ever, have access to an AWS data center. Maybe if you're a big enough customer, you can arrange a tour, but that's about it. AWS simplifies the process of designing and deploying solutions that are secure, scalable, highly available, and fault tolerant. To do the same on-prem is not only a challenge, is in some cases, for many organizations, cost prohibitive. So it makes comprehensive security available to the masses. It really fits into the whole model of why cloud is an advantageous approach to implementing your solutions in the first place. Summing up, when you move to AWS, your security posture will generally be higher than what you were able to achieve on your own, because you inherit a global set of controls that are set to the highest levels of compliance for some of the highest industry standards that are out there. And ultimately, in achieving compliance with all these different entities, whether it's ISO, International Standards Organization, or it's NIST standards, or it's PCI DSS standards, or it's SOC standards, it's European standards, or all the different countries in which they operate. All the standards have to be met by AWS. And while there'll be some variation based on where your region, what region you choose to host your information system, even if you're across the board, you'll find there's a standard of security that meets the majority of those regulatory standards just as a default. And then within a given region, there could be some additional customization to meet the local regulations. Automation, deeply integrated, the highest standards of privacy. And we know privacy is a great concern, not to mention the fact that they have a ecosystem of partners to provide solutions that even augment what comes natively in the AWS environment. And when you think about that, you find that if you're satisfying the military, banks, other highly sensitive organizations, you're giving them industry-leading security teams around the clock, 365 days a year, and you're leveraging all of that experience to continue to improve the services with every new iteration, providing native functionality and tools without each organization having to go out and buy all their own equipment and technology, meeting all sorts of compliance. It's not surprising that the CIO of a major bank, Capital One, would say, we work closely with AWS to develop a security model which we believe enables us to operate more securely than the public cloud than we can in our own data centers. That's a statement that really shows the advantage of AWS as your platform for a secure information system environment. Now, Amazon Web Services covers a litany of services and products on more or less a stack. You could call it the platform, you could call it the stack. You'll notice at the bottom, you deal with the global infrastructure. Built upon that are our core networking components. Built upon that are our core computing and storage components. And then a variety of services that work up and down the various layers of the stack. We'll talk more about some of these in due turn, but any detailed, in-depth discussion of each of these would require you to go ahead and attend one of our full AWS classes. We leverage a global infrastructure with growth. In addition to the 60 available zones and the 20 regions all around the world, new zones are coming online in South Africa, in Hong Kong, and Bahrain, Milan, a growing infrastructure. Now, I want to back up for a moment and just talk a little bit about cloud computing in general, because to understand the security features, we need to understand really what's our objective here. What are we dealing with? Cloud computing is just a term. It's the buzz phrase. It's the term that everybody loves, and it creates a great deal of imagination, and it stirs a different thought of the obfuscation of your hosting solution. But in the end, it's just a way of describing converting geographic location-oriented data center hosting to ubiquitous, abstract, universal information system hosting. The idea is to virtualize your use of data centers, virtualize your use of information systems by leveraging the global internet work that we call the internet in order to deliver solutions where it's needed, whenever it's needed, to whomever needs it. And these typically operate at various levels of application, platform, and infrastructure, which is why we have the terms application as a service, platform as a service, and infrastructure as a service. This concept of delivering information system solutions in an abstract, virtualized network, internetwork-based model allows resources to basically be used more like a utility than an independent, home-run, home-built, home-managed system, an on-prem environment. With that, with the use of certain technologies like SOA, for instance, it's made the ability to take that concept and make it highly effective. And service-oriented architecture is basically a way of building applications so that they can work in an environment where location is irrelevant, where the actual host device is irrelevant, where ultimately a call can be made, the response is self-contained, everything's a black box to the outside, and you can obfuscate the internal operations of a system from the external controls, handles, API to communicate with that system. So with this approach, combined with operating system virtualization, we again can take applications that were designed to work in componentized fashion, in an object-oriented structure, and then decouple the systems from the physical environments through virtualization so that really what bare iron a given system is running on is irrelevant. We're dealing with a logical object that could be anywhere. So now we're basically breaking our applications into logical components that can be anywhere. We're breaking our machines into logical objects that can be anywhere. And with that, we can create levels of scalability and redundancy that are greater than what we used to have to do in the old days with location-centric computing. Another consideration as to why there are advantages to cloud in general is just the costs and challenges of managing data centers. Data centers, when done right, will have many characteristics that cover not only security, but continuity and full availability or high availability, preferably, with monitoring capabilities and all the necessary things to guarantee a maximum uptime. If possible, perfect uptime, or as close to it mathematically as we can get. We'll take 5 nines, but if we can do better than that, that's even better. Another need that's achieved or that's mitigated, managed, dealt with through cloud platforms is the distribution of those data centers into geographic disparate areas so that you can always have resources that are proximal to your users, wherever your users may be in the world. So the greater the international exposure of a given organization, the more geographically distributed the application needs to be, or the systems need to be. Not only for purposes of continuity, where we have primary and failover capabilities, but also to lower latency and improve overall performance wherever you may be. And that's really the reason why Amazon is the leader in this. Their build out during the .com bubble of an international network with data centers all over the world and overcapacity to handle peak purchasing seasons like Christmas season and so forth, created a situation where they had economies of scale that they could leverage and sell to others. Now, other organizations can use their international network of data centers for a much lower cost than building the same thing yourself. Now, the way the cloud computing breaks down, as we talked about briefly in the outset, 3 basic layers: infrastructure, platform, and software. Now, it's important to note that these are not hard and fast necessarily. In some cases, you'll find solutions are kind of hybrids between software as a service and platform as a service, or maybe a blurred line between infrastructure as a service and platform as a service. So they're not necessarily meant to be a rigid set of rules or descriptions of how cloud computing works, even in the AWS environment, but they do give us a model against which to discuss and describe the nature of security and capability implementation in the cloud environment. Now, more specific to the AWS Cloud Computing Platform, we can divide our understanding of this environment into these 4 tiers. Now, whatever your applications are, they're going to take advantage of the management and administration interface and tools. In some cases, you may have an infrastructure as a service where you utilize very few of the administrative and management tools. But in a platform as a service deployment, you may utilize, say, Beanstalk as a means to standardize the solutions that you're using. Let's say you want to build an application on a LAMP stack, you could use their LAMP stack. They take care of all the goodies with that, and you just have to manage your application. So that would be more of a platform as a service. But if you want to get down to just using your EC2 instances, just using your S3s or RDS instances, then essentially they're providing for you a standardized infrastructure, and you build everything within it. Now, depending on where you work between these various layers, will give you a picture of what kind of security solutions you may have. So whether we look at the individual services, and there are a great many of them, or we look at them in terms of an application stack, the advantages are still unquestioned. You have, with this approach, what I like to call centralized decentralization of a multi-tier application architecture. Centralized in the fact that you can just refer to the cloud monolithically, as if to say, we're hosting our applications in the cloud, as if that's just one place. So in a sense, centralized. But in reality, it's a geographically distributed environment. Therefore, you're decentralized and you're componentized, and you're fully object-oriented in your architecture. So you're completely decentralized in the way your application works. So it lowers the costs of doing decentralization, and it lowers the management of doing this distributed decentralized applications with the centralization of the single virtual environment, the AWS cloud. Pay-as-you-go pricing, elasticity, flexibility, speed, agility. Apps, not ops. You're focused on what you're doing. You don't have to be focused on operations, which is part of that utility architecture or orientation that it gives you. Global reach, flexibility, and of course, what we're talking about today, security. So security in the cloud, particularly the AWS cloud, is based on what we call the shared security model. This basically means that just because you choose to host your applications in the cloud doesn't mean you're just offloading all of your security responsibilities. Some years ago, I actually wrote a paper for the United States government on that subject. It was called The Security Black Hole Between Information Systems and Infrastructure and Platform as a Service Cloud Architectures. I know it's a boring title, but the point is, sometimes people don't recognize the shared responsibility in hosting solutions in the cloud. While the AWS environment gives you a great many handles on your security, it does not replace the need to be security conscious and security focused as a customer, as an information system owner, those ultimately responsible. But when you look at the way the shared model breaks down into actual security controls, you can look at the controls in terms of your inherited controls, controls that are fully taken care of by AWS. And these will always include your physical environmental controls. So the gates, guards, guns, all the things that physically protect your site, the environmental controls for power, fire protection, HVAC, all of those controls that are data-centric or data center-centric, they're completely responsible for that. That is completely offloaded from you as a purchaser of their services. But shared controls could really cover anything else. Now, this is where that line that I talked about in just looking at the pyramid, the model of infrastructure as a service as a baseline and software as a service as more given to the responsibility of your cloud service provider. It really depends. For instance, patch management. Well, AWS is going to be responsible for patching any services within their infrastructure that you are purchasing from them or you are utilizing from them. You don't have to maintain or patch anything that's included in what they're delivering to you. So if you're in a platform as a service package, you're utilizing an environment where they're taking care of maintaining the security baseline on, let's say, an RDS that's based on Oracle, for instance. You don't have to worry about patching Oracle if your usage of Oracle is through RDS. If, though, you're utilizing an EC2 and loading your own Oracle implementation, then you're just essentially leasing a box at that point. You would be responsible for patch management in that situation. So it's going to depend on what the host to guest line happens to be. the more services you utilize, the more responsibilities fall on AWS. Now, that's not to say that they'll ever take care of patching a guest OS or application that they're not implementing as part of their service. That will always be on you. And along with that goes configuration management. Anything that you're managing as a guest in their environment where they're just providing the bare metal, well, configuration management is entirely up to you. If though you're utilizing a service, then configuration management will be more of a shared responsibility. But even when they're providing as a service, configuration management is generally weighted toward the customer. Now, what I mean by that is this. Just because you utilize a system doesn't mean that you're not the one configuring it. And it also doesn't mean that you couldn't configure it in such a way that creates vulnerabilities that would not necessarily be the case if it were implemented a different way. So your awareness of sensitivity and configuration requirements for a secure configuration could very well depend on you. AWS training, well, there's a great deal of training that's provided from AWS, but in the end, awareness training is ultimately the responsibility of the customer when it comes to their own employee. Now, AWS trains their employees, well, you'll train yours. And then lastly, we have customer specific. These will never be the responsibility of AWS. And this is anything in your architecture that is really outside the scope of a service that they're providing. And that could even include various services and communications protections that are not handled by AWS. So summing up the shared security model in a graphic, you can see everything that deals with the data, any hosted or guest systems, any scripts that you create, even your use of encryption, both for data at rest and data in transit, all of that is configured by you. So in the end, the customer is responsible for that level of security. It's described as being the security in the cloud. That's the customer's responsibility. But the security of the cloud is AWS. So the software, and that includes maintaining a security baseline for any service software that's provided as a service to you in the platform that you choose. So you don't have to worry about maintaining the latest service release on the version of the RDS that you have. You just have to indicate what RDS you're using, and that level of patching is done for you, so long as your application is riding on top of it and is written in accordance with a proper object-oriented strategy that allows you to utilize their service abstractly. Anything in terms of the computing platform, storage platform, database platform, networking, they take care of all of that. Of course, the hardware and the global infrastructure is their responsibility. They're responsible for the security of the cloud. You're responsible for security in the cloud. And because you're responsible for security in the cloud, good cyber hygiene comes to the fore. Really, when you actually look at what happens in the way of security breaches and incidents, the majority of the incidents that are reported, and even some that are not necessarily reported, when you do a postmortem, you do an evaluation of exactly what went wrong, it's not hard to find the fact that the majority of the breaches could have been prevented by good cyber hygiene. And cyber hygiene is simply the process of implementing security best practices that are clearly known and understood. Segmenting your networks, compartmentalizing user permissions. Don't just give everyone blanket permission to everything. Good password rules if you use passwords at all, or strong authentication, even better. Making sure the firewalls are implemented correctly. Blacklisting environments as appropriately. Making sure your antivirus and spam protections in place. Making sure that there's no unauthorized software, rogue software, or hardware running. Firmware and software patches are current. All of that basic stuff. It's good cyber hygiene. But you'd be surprised how many organizations fail to meet those simple baselines of security. It's crucial, though, that this is monitored on a regular basis because, as I mentioned on the slide here, cybersecurity is a moving target. There's no such thing as, a secure system in an absolute sense. What is considered secure today is not secure tomorrow. And sometimes we find vulnerabilities in our actual security mechanisms, or the technologies we implement for security. For those who've been around at least a few years, you may remember Heartbleed, a flaw in SSL, the core security protocol that we use for protecting data in transit across the web. We thought that was all secure. We found out that it wasn't very quickly. It became a very urgent matter of remediating that flaw. So we can never just say, hey, we've set it up and we're good. We have to maintain good cyber hygiene. Security covers three principal areas. Now, there'll be other professionals that will argue that there are more areas of concern, and that's not necessarily wrong. But you can roll up most of security into these three basic areas. Confidentiality, that is allowing only those who need to know. Availability and integrity. With confidentiality, only properly authorized parties get in. With integrity, the information is exactly what it's supposed to be and nothing different. It's not been modified. It's not been destroyed. It is sure and secure. And with integrity comes a variety of other considerations, like non-repudiation, authentication, AAA security, for instance. Availability is what I consider to be the basis for everything we do in information technology. In the end, the computer system is there to deliver a solution to some problem, to some business need, to some organizational mission need. If it's not available, it's not serving its fundamental purpose, its reason for existing, the basis for the whole budget. So in the end, maintaining availability is a critical concern of security. Now, there are all sorts of threats to confidentiality. Anytime someone's trying to compromise the content of your information, it's a threat. We mitigate this through encryption, through obfuscating our traffic within networking, our network traffic. This is what we call traffic padding, good access controls, proper classification, and of course, training our people, which is generally the weakest link. Privacy and confidentiality are hand in hand. So when it comes to privacy, there's a great deal of attention in the AWS platform given to it. There are residency requirements to meet whatever the regulatory or statutory expectations are for privacy standards. Encryption is managed and scalable, whether you use the key management service or even if you want to meet extremely high-level encryption requirements through hardware security modules. There's a capability to implement, FIPS 140-2 level 3 validated HSMs. Whatever the laws may be, the AWS environment is meant with a compliant, privacy-compliant infrastructure. Integrity is, again, whenever we're trying to interfere with the validity of the content or the existence of the content. So virus, logic bombs, user errors, all these sorts of things can affect integrity. And there are a number of technologies that we use to mitigate against integrity risks. Availability is what most of the technologies in a globally distributed cloud-based environment is designed to mitigate. So availability is of high concern. So looking at the three in the cloud, confidentiality will depend on the configuration of the system. In many cases, while the AWS platform gives you all the tools you need to maintain a high level of confidentiality, the configuration of the system and the utilization of that technology will depend on the system owner. In terms of integrity, in many cases, it's a matter of cyber hygiene, but whatever the standards are, the system owner has to make sure that they're meeting their standards. AWS has very high standards. And to the extent that you use AWS services, particularly higher toward the SaaS level, they'll take on more of that burden. But if you're more down to the bare metal side of things, then that's an option as well, but then more of the onus is going to be on you. In the end, all the tools you need to maintain a high integrity system are there. And of course, the availability is second nature with the design of the fully redundant global infrastructure of AWS. Their principal goals is to keep your data safe. The physical protections are consistent across the globe with all the data centers. And it's not an insignificant level of security. I mean, the physical security, all staff have to go through two-factor authentication at a minimum of 2 times and on any floor of the environment. I mean, you can't even get a guest pass to go in these places. They're extremely secure. All activity is audited, logged on a constant basis. Fire detection and suppression is in place in these infrastructures. Power is designed to be uninterruptible and generally with separately redundant connections to, depending on the infrastructure of the location or the region in the country. It's going to be basically the most redundant and fully enabled services available, and even that will be redundant. And there'll be backup generators and so forth to make sure that everything is maintained. You know, the management of electrical, mechanical, and life support systems is 24/7 with fully trained staff. So it's a very high concern. And as I mentioned before, AWS is designed to meet the compliance of all sorts of organizations. So the best practices of the industry are already built in. And with availability, you also have the capability to scale quickly, to have your systems replicated across multiple availability zones and so forth, and to do all of this while saving you money. When we look at the capabilities that are in the infrastructure itself, is your virtual private cloud, your VPC, will already have firewalls built in, web application firewall capabilities. You can create your own private networks and control it with all of the power of using the state-of-the-art Cisco, Juniper, whomever systems that you can imagine. And the beauty is with the these services being handled in an abstract sense through the virtualization of the cloud environment, you know that you're getting the cutting-edge capabilities with a near real-time security baseline in terms of the state and status of those controls. Encryption in transit is available. Connectivity options, make sure that your private or dedicated connections are available to you so that you don't even have to come in through the web to attach to your VPC. All part of just the platform. You know, a big concern with cloud-based architecture or any web service is denial of service attacks, distributed denial of service attacks. And again, when it comes to the AWS environment, the technology to provide resilience is the foundation of the entire architecture of the global infrastructure of AWS. So these services are already layered to give you defense in depth to thwart DOS attacks. They have control mechanisms built into their environment. And depending on how you tier your system, your own architecture could thwart DOS attacks if you have a properly redundant and distributed architecture within the AWS environment. They have automatically response to what appears to be DDoS, so that any time or impact is minimal if it happens at all. And then the core technologies like auto scaling, which if there's a lot of traffic coming in, you auto scale up anyway. So even before the attack is recognized, it would not necessarily interfere with the continuity of operations. And CloudFront and the way Route 53, their DNS service, all works, is designed around this persistent threat and how to manage it. As I mentioned earlier, data encryption is provided at every level of the organization. So when it comes to your data at rest, well, any storage or database service solution that AWS provides the ability to encrypt using the best standards of the day, which is currently AES compliant. But it's not. I don't want to get into the specific encryption mechanisms because it can vary. It depends on what service you're doing. But just as a standard, whatever is the current state of the art, that's going to be the current service provided. And the key sizes are moving up as the technology moves forward. For instance, when it comes to the key pairs that are provided in communication with your identity management and access control, would be a 2048 secure shell key. And that's just for the basic communication. So, the work factor on a key that large is significant. That's just give you a picture of the state of the art that we're dealing with. But however you're dealing with keys, they have a key management service that's available to you so that instead of managing your PKI yourself, you can just control the use of your key and key pairs and your PKI architecture, but utilize the actual operational capabilities of the AWS teams and AWS environment. Any message queues, if you actually build your applications in more componentized fashion, well, even the communication between your application tiers or your queues are going to use server-side encryption. Hardware-based keys, and if you want to use, as I mentioned before, hardware-based keys to meet even a higher level of rigor that's available to you as a solution. In terms of tools to ensure that your resources comply with standards, there is an Amazon inspector that provides a security assessment service. There are deployment tools for creation and decommissioning, and making sure you can build out in accordance with your standards from jump. CloudFormation being certainly part of it, with templatizing your architecture. And of course, if your needs are for high configuration management, secure configuration management, AWS Config allows you to do the equivalent of what Tripwire does in your own environments. We can manage in real time any configuration changes, so that if there's any access creep or any security creep that takes place over time, there's a mechanism to actually have auditability and accountability and manageability of any configuration changes. And that gets me into monitoring and logging. There's deep visibility into any activity that takes place within the AWS environment. The tools CloudTrail and CloudWatch, log aggregation options, and the ability to even utilize industry standard tools like Splunk and so forth, ArcSight for aggregation, and various tools that are available to you. So you can spot potential issues, identify aberrant or abnormal information, and reduce the risk to the organization in real time, but also have the forensic capabilities of going back and deconstructing any activity that may have been unauthorized or unintended, or in worst case, malicious. Talk a little bit about identity access control, but it's important to understand that you have control of your IAM and IDM services within the AWS environment. All the tools that are there. You can define user accounts to do user level discretionary access control. You can implement multi-factor authentication for privileged accounts. In some cases, even using hardware-based authenticators. In other cases, you can simply use cell phones to use a third factor in validating access control. Whatever the case is, the tools are there. If you want to use federated services to simplify your directory service access and access controls for single sign-on capabilities, it's native in the environment. It's available to you. You want to implement your own API for additional access control, it's certainly possible. So even beyond the ones that are out of the box services, you have total access. The thing is, in the end, the security of your environment is largely up to you. All the tools and capabilities for security are there, together with training and assistance to give you the best implementation of their solutions. But in the end, tight access control is up to you. Strong authentication is not required. It's an option. So you have to actually configure multi-factor authentication if you're going to do that. It's a good recommendation to minimize the accounts that have administrator level access. That's what we talked about earlier about segmenting and tiering your access. Using the IAM features is a good way to do role-based access control and to limit even the visibility of constrained user roles. Configure rule sets on your firewalls. A best practice is to deny by default, permit by exception. AWS gives you the capability to do all this, but it's up to the individual to properly harden their VPC. Now, once you've done all that good stuff, you still don't really know, so you need to test. AWS allows for vulnerability assessments that include penetration testing. You simply have to submit the appropriate forms to request penetration. And once you do, there are certain rules you have to play by, because in the end, penetration tools are hacking tools. And with all the security that's built into AWS, we don't want friendly activity mistaken for malicious activity. So obviously we need permission. The only one who can get permission is the user that has root level credentials. And then you're only going to be able to test instances you own, EC2s and RDSs that are yours. At this time, small instances that are on a shared platform, like the micro instances, do not allow for vulnerability testing, at least not through penetration testing. And that makes sense. If you're on a shared platform, what happens to one instance could affect others on that same box. So that's not permitted at this time. Continuity of operations, as I've mentioned several times, is intrinsic. If you have this many regions and so many availability zones in each of these regions, and in each of the availability zones, you have a variable number of data centers, you have a tremendous amount of redundancy before you even think about looking at your continuity of operations. Now, you can employ additional services, like for a cost. You can do what we call multi-AZ replication, where you're not just replicated across several data centers in the same availability zone, which is what you get by default, but you're across availability zones to provide a greater level of security. But that's par for the course for commercial and industry level uses of AWS. In other words, if you're big enough to actually have high availability service, then it certainly is available to you. So that improves. So that includes replicating across multiple data centers. That includes all the growth that's taking place with new availability zones, more regions, and then the meeting of compliance in each of those regions. Speaking of compliance, the AWS Compliance Program is exhaustive. This graphic kind of gives you a bit of an impression of all the different organizations that the AWS platform is designed to meet. But this is not an exhaustive list. This list, though, does give you a picture of the level of standard that's expected, like PCI for commercial purposes, FIPS and NIST standards for the US government, including DoD standards to meet even the use of military services. International standards, both from 9001 to 27000 and all the rest. Again, this is not a complete list. The UK standards, Austrian standards, Australian standards, Canadian standards, all across the globe, these being just a glimpse of what's capable. Now, the regionalization of compliance does vary from location to location, and AWS is designed to customize as needed to the local statutory requirements. But when you meet some of these standards, you're going to generally cover most of the rigorous standards that are found around the globe. Usually, any changes are just one-offs, sometimes in the area of privacy, like European privacy rules were just tightened very recently. So you'll get a little variability, but for the most part, by planning for the high watermark, AWS compliance fits in with just about everything. In addition to all of this, there are best practices and white papers, security bulletins, developer documents, and advanced innovation reports that give you a library of resources online to make sure that you both understand what AWS is doing, but you're able to actually take advantage of the services that are provided. If you need more, they have expert guidance services through AWS Trusted Advisors or third-party strategic partners that can create additional solutions. And then, of course, you can get their professional consulting services for in-depth security solutions as well. Of course, it's a for-fee service to actually have their solutions teams helping you actually implement your enterprise implementation for the AWS environment. Their ecosystem of partners, though, covers pretty much the whole industry because they are the industry leader. They're the industry leader because they were the first to really create a viable approach for cloud computing as we know it today. Everybody else is still playing catch up. Not to say that the Google Cloud isn't great and that the Microsoft Cloud isn't closing rapidly. They're still playing substantial catch up. And even as they're playing catch up, AWS continues to move forward. So pretty much all the big names in the industry are within their partner and solution ecosystem. So in addition to all the resources that AWS gives you directly, you can work with infrastructure security organizations, access control security organizations, configuration vulnerability analysis organizations, and even the logging and monitoring state-of-the-art tools like Splunk and so forth. All the web services across the entire Amazon Web Services platform are built on these principles and these tools cover the gamut. So in summation, AWS basically solves some of the big challenges in security management, and it does it at a low cost. As a baseline, just as a starting point, you'll find that the AWS environment is probably more secure than what most organizations, both public and private sector, can reasonably achieve within budget and scope. But maximizing that security will always be a shared responsibility. AWS is responsible for the security of the cloud. Your organization will be responsible for what you put into it. But AWS does simplify all that it takes to design and deploy your secure, scalable, highly available, fault-tolerant systems. The tools are there, state-of-the-art tools that cover all of what any security-sensitive organization would need to have in place, because it's designed to meet some of the strictest security guidelines in the industry. Like I said, even the U.S. government and the military make use of AWS for certain services, let alone banks. And you saw what Capital One had to say about their experience in using the AWS to provide their capability solutions. In the end, you got to identify and employ the appropriate use of AWS architectural best practices to get the full bang for the buck. But all the tools are there. With that, we can spend our remaining time. We have just about 5 minutes left to talk about questions.
You guys feel free to type in the questions in the Q&A section, please. So in case you have any questions later, please log into expertconnect.quickstart.com. It's an IT community which is a primarily Q&A based IT community where you can ask questions and get answers. You can also reach out to me at marketing@quickstart.com. We will definitely be doing another session on AWS technologies with Michael in the very near future. So there is a question from Travis Taylor. Specifically, how long will it take to learn or get a good understanding of all these features?
That's a that's a very open-ended question. I mean,
yeah. So it depends on the type of learner as well, right? And
it
and
certainly
then
does.
your background and
Yeah, I mean, we do have courses that I teach that are about a week long that are just oriented around the solution architecture certification. But even that, I wouldn't say is comprehensive in any one area. I mean, this is going to be an area where, in all truthfulness, you can be a lifelong learner because as the technology matures and changes, there's a lot of relearning that takes place. And I've been in this business for many, many years. And, when I started programming, I was programming on mainframes. I don't use very much of my, COBOL and Fortran experience anymore. So when it comes to technology, there's a baseline of expertise that you can achieve in a matter of weeks to months. But even then, there's much, much more you would need to learn on any given area. And using it in your job is probably always going to be the best way to learn. Sorry to give you kind of a dodge on that question, but get a good understanding of all these features. I mean, in a week, you could get a much more, comprehension of it. Certainly, well enough to take a certification exam, for instance. But I would still say that's a starting point more than a comprehensive understanding.
Yes, and with new technology, there's always new security threats as well, and
Absolutely.
Then there are new ways to identify them, new ways to counter them.
Absolutely.
Okay, Michael, thank you. It was a very educational session. Thank you, everyone, for attending. Thank you, Michael, for the wonderful session. We will see you guys next time. We'll keep doing these webinars, and we'll definitely be doing one more on AWS. We'll see you guys next time. Thank you, everyone. Have a nice day.
Thank you, everybody. Take care.
Thank you. Thank you. Bye.